In this video, I will show you how to factor a variety of polynomials such as these. We will use a combination of factoring out the GCF, the greatest common factor, also difference of squares, and also we will factor trinomials like this one using either the box method or the grouping method. The first step of factoring is always to look for a common factor. In this case, I see that both terms have x's. So I'm going to have a variable in my common factor. But how many x's should I have? Well, you always go with the lesser amount. So I see x squared is the smallest number of x's. So that's going to be my GCF, my common factor. And then I'm going to have some parentheses. Now, to figure out what goes inside the parentheses, I need to divide by my GCF. So I'm going to divide by x squared. So if I do that, x to the fourth power divided by x squared is x squared. And over here, the x squares cancel each other out and just leaves 3. So I should look at what's inside the parentheses and ask myself, can that factor any further? Well, if you have a binomial and there's no GCF, then the only thing we know is difference of squares. Well, this is a sum, not a difference. So right away I know this is not the difference of squares, so this cannot be factored any further. So this is the final answer. Would it confuse you if I mentioned that there is a such thing as the sum and difference of two cubes? Alright, and you can factor this, but that is beyond the scope of this course. So that's something that you're going to learn about in a future course. When you have a trinomial, you should be thinking, I'm probably either going to use the box method or grouping in order to factor this. Those are the two main ways that we use. On this problem, I am going to use the grouping method. So first you look and see, is there a common factor? Nope, there is no common factor. So I move on to finding a product and a sum. I need a product and a sum that involve the same numbers. So the product has to be A times C, 1 times -4. So the product is simply going to be -4. The sum has to be the B value, so the sum is -3. Now, back to the product. I'm going to make a little list using the product, or I'm just using 4, not -4. But what times what makes 4? Go in order. This will either be 1 times 4 or 2 times 2. So it's a very short list. Now, which pair of numbers will give me a sum of -3? Well, that's going to be the 1 and the 4. If I use 1 and 4, I can get a sum of -3. If I choose the signs right. If I have a +1 and a -4, that adds up to -3. Then I have to use the same numbers for the product. So 1 times -4 is -4, so it works. Now, for the grouping method, at this point, you take the first term and you just bring it straight down. So here's my x to the fourth power. Skip the middle term for now. Take the last term and just bring it straight down. Now, here's what you do with the middle term. We actually have to take the middle term and split it apart into 2 terms, using the 2 numbers that we just found. So instead of writing -3x squared, I'm going to write plus 1x, or I could just put plus x, and minus, whoops, I shouldn't say x, I should say x squared okay, because that's 1x squared, and then negative 4x squared. All right, I almost put x by accident, but this is x squared, so when I split it apart, it will still be x squared. So there's my 1, and there's my negative 4. Now I'm going to do the GCF of the first two terms, and I will do the GCF of the second two terms. So the common factor from the first pair is x squared. All right, that's the GCF. And then I'm going to have some stuff in parentheses. Now, the common factor for the second pair is going to be negative 4. And then I'm going to have some stuff in parentheses. Okay, now on that last one, obviously both of these are divisible by 4. I put negative 4 because if the first term is negative, then your GCF is negative. Now, to figure out what goes inside the parentheses, you divide by the GCF. So I'm going to divide these two by x squared, and I'm going to divide these two by negative 4. So inside the parentheses, I'm going to have x squared plus 1. Okay, and then over here, the negative 4's cancel each other out, so I'm going to have x squared. Negative 4 divided by negative 4 is positive 1. Notice how the parentheses are the same. Whenever you do the grouping method, the parentheses should be the same. If they're not, you made a mistake and you need to go back through your steps and see what you did wrong. Because both of the parentheses are the same, that means that they are a common factor. And whenever you have a common factor, you pull it out to the front. So I'm going to write my x squared plus 1 out in the front. I'm taking them away. If I pull away the x squared plus 1's, that's going to leave behind these blue terms. That's going to leave behind x squared minus 4. Now, you should always look at your binomials that you have here and ask yourself, can either one of these be factored further? And because they are binomials, our only real hope is the difference of two squares. So the first one is a sum, so that can't be factored. It's not a difference. The second one is a difference, so maybe. 4 is a perfect square. And of course, x squared is a perfect square. So this is the difference of two squares, which means I definitely need to factor this more. So using the difference of squares pattern, x squared minus 4 will factor as x plus 2 times x minus 2. We're just splitting everything evenly apart. And 1 plus and 1 minus. As I said, the x squared plus 1 does not factor because it is a sum and not a difference. So because it cannot factor, then we will just bring it straight down unchanged. And that makes this the final answer. So this is a binomial. So I'm not going to do the box method. I'm not going to do grouping. It's just going to be a GCF and possibly difference of squares. That's all I got. So let's start with GCF. Whoa, I'm noticing I have two different variables. So slow down. So actually, because these are different variables, there is no common variable. However, both terms are divisible by 3. So I can pull out a common factor of 3. Now, if I divide both terms by 3, that's going to leave behind m squared minus, whoops, I almost forgot the 27 divided by 3 is 9. I almost forgot the 9, so this will be 9n squared. So I did the GCF. So look at what's left inside the parentheses. Can this be factored any further? Well, it's a binomial, so our only hope is the difference of squares. Well, guess what? This is the difference of two squares. Difference means subtraction, and this is subtraction. And m squared and n squared are perfect squares. 9 is also a perfect square because that's 3 times 3. So we should be able to factor this further using the difference of two squares pattern. So we will do m plus 3n and m minus 3n. Don't forget to include the GCF that you pulled out in the previous step, and that will be your final answer. For number 16, we have another binomial. So that means no box method, no grouping. All we have is GCF and difference of squares. Well, guess what? There is no GCF. There's no common factor. So that just leaves difference of squares. This is the difference of squares. It's the difference because it's subtraction. A squared and b squared are both perfect squares. Obviously, it says squared right there. And 9 is a perfect square because that's 3 times 3. So all we have to do is use the difference of squares pattern. Alright, which says we're going to have 1 plus and 1 minus. And everything will be factored evenly, split right down the middle. So a squared will just be a times a. And 9b squared will be 3b times 3b. And that's it. That's the final answer. Number 17 is very similar to number 16. It's a binomial, so that means there will be no box method and no grouping. So all we have to worry about is GCF and difference of squares. There is a GCF on this problem. So be careful because you might be tempted to go straight into the difference of squares because 4 and 16 are actually squares. But that would be wrong. That's going to leave you with more common factors left inside parentheses. So always start by taking out the common factor. Both of these are divisible by 4. So that is the common factor. And then if we divide by 4, that's going to leave x squared minus 4y squared. Now, notice that x squared minus 4y squared, the parentheses have a difference of squares inside. So that means I can factor this further using the difference of squares pattern. So this is going to be x plus 2y times x minus 2y. Don't forget to bring down your GCF of 4, and this will be the final answer. Alright, number 18 is a binomial. So no box method, no grouping. Just GCF and or difference of squares. Let's see, there is a common factor. Both of these are divisible by 4. So start by pulling out the GCF. Now, if I divide each term by 4, that's going to leave behind u squared minus v squared. This is the difference of squares. So that means I need to factor this further using the difference of squares pattern, which goes like this: u plus v times u minus v. And don't forget to bring down your common factor of 4. So this is the final answer. In this video, I will show you how to factor binomials such as these. And because they are binomials, we won't be using the box method or grouping. All we have is greatest common factor, or GCF, and difference of squares. So those are the two techniques that we use when we have a binomial, two terms. We always start with the GCF. So looking at problem number 19, what is the common factor? Well, both of these are divisible by 2, so I'm going to bring out a 2. The variables are not the same, so there's no variable part of the GCF. Now if I take that 2 out, that means I'm really dividing everything by 2. So that tells me what goes inside the parentheses. So that's going to leave x squared minus y squared. Now, is this the difference of 2 squares? If it is, I need to keep going. Well, it's the difference, because difference means subtraction. And both of these are squares. So this is the difference of squares. So I need to factor using the difference of squares pattern, which says when you have x squared minus y squared, it's going to be x plus y times x minus y. So x plus y, x minus y. And then you keep the 2 in the front, and that is your final answer. Now look at problem number 20. Is there a common factor here? Well, both of these are divisible by 5. So 5 is going to be my common factor. If I divide these by 5, I'm going to get m squared minus 25n squared. I'm pretty sure about that 25, so let me just double check. 125 divided by 5 is 25. Now, inside the parentheses, this is the difference of 2 squares. 25 is a perfect square. So we need to keep going and factor this further using the difference of squares pattern. One will be plus, one will be minus. And everything gets split evenly. So I will have m plus 5n and m minus 5n. And bring down the 5, and this is your final answer. So looking at number 21, what is the common factor? Well, both of these are divisible by 4, so I'm going to pull that 4 out. And if I divide everything by 4, that's going to leave u squared minus 25. Okay, but u squared minus 25 is the difference of squares. So I must keep going. The difference of squares pattern says this will factor as u plus 5 times u minus 5. And you bring down the 4, and this is the final answer. Okay, problem number 22 has no GCF, but it is the difference of squares right now. So we can just go straight to the difference of squares pattern. So this should be x plus 4y and x minus 4y. Everything just gets split right down the middle. 1 plus, 1 minus. So that's it. This is the final answer for number 22. Okay, last two. Again, number 23 has no GCF, but that's okay. It's already the difference of squares. So I'm going to go straight to the difference of squares pattern. This should be m plus n times m minus n. And that's all I have to say about that. Last one. Again, there's no GCF, but again, this is the difference of squares right now. So I will go straight into the difference of squares pattern. So this should be x plus 2y times x minus 2y. And that is the final answer. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.